top-secret Nazi facility with aims for the stars.
The genesis of the space program was military. How to attack your enemy. That was the start of the space program.
A huge, abandoned tower dominating the landscape.
Not only is it functional, it's intriguing to look at.
And a shocking machine that strikes with lightning force.
That thing is just immense. It's a man-made wonder of the world.
Once, they were some of the most advanced structures and facilities on the planet. At the cutting edge of design and construction. Today, they stand abandoned, contaminated, and sometimes deadly. But who built them and how? And why were they abandoned? Rising above the Oka River in western Russia is a revolutionary engineering landmark. This abandoned tower stands nearly 420 feet high, is only 98 feet wide at its base, and is made entirely out of steel. Despite its massive height and narrow base, this latticework of interwoven steel still stands as a true engineering marvel.
You look at it and you're not entirely sure why, but you know there's something different about it. It's got a curved profile, it has a curved shape to it, yet all the members and the constituents of it are long and straight. It's a work of art, it's a work of engineering, it's a work of maths.
It's almost mind-bending looking at that thing. It looks like there's all this curving steel. You've got to remember, every piece in there is straight. How do you work out how strong this structure is going to be, how resilient it's going to be to wind and all these sorts of things?
But who built this stunning piece of architectural engineering? What was its purpose? And why was it abandoned? In the late 1920s, the newly founded Soviet Union has an electricity problem in its city of Nizhny Novgorod, east of Moscow. Both its military and industrial resources need more power. But to deliver on that, they must create an unprecedented electrical tower with far-reaching capacity. The man who dreams up, designs, and builds this groundbreaking structure is Russian engineer and scientist Vladimir Grigorievich Zhukov.
I think the Zhukov design is very pioneering because a lot of these masts were there to be practical, and we just needed to get the height, and we wanted to do it with as little steel as possible and just get up there. But I think Zhukov thought a little bit deeper about the problem. He thought about how we could actually make it look beautiful, how it could be mathematically very precise, and he came up with what I think is a very, very beautiful and unusual structure.
This is the revolutionary Zhukov Tower. It is one of 6, built in 1927 to carry power lines across the Oka River to vital Soviet industries in the city of Nizhny Novgorod. 260 miles east of Moscow. Engineers begin working on one of 2 towers standing on the north bank of the river. But at a staggering 420 feet high, will Zhukov's revolutionary design be able to cope with the weight of the cables and the effect of the wind blasting against it?
Any engineer designing a tower that's going to be hundreds of meters up in the air needs to consider the effect of wind. That wind is going to be striking, even if you can't feel anything on the ground. Up there's going to be forces acting against your tower, effectively trying to bring the thing down. If you look at an example like the Eiffel Tower, you can take a look at that and say, it's quite a squat structure. It's got a wide base and it kind of tapers in towards the top. That looks pretty solid. Zhukov's towers don't have that. They're much more graceful, yet somehow, using his mathematical mind and putting that into practice, he's created towers that have that grace and elegance, but still do the job.
He must have had to do so many calculations to work out whether this thing was feasible. Kept it in that simple, elegant, beautiful design. Almost transparent nature. All those beams are very, very thin, that you can imagine wind being able to pass through it without causing that much of an issue. So in a way, it's very efficient, if complicated design.
But as stunning as the design is, building a tower of this astonishing height requires an innovative approach.
I think the way that they built the Zhukov tower is actually quite clever. So they started off with the base and then lifted the segments through the base and then placed it on top. And that actually works quite well because you could put the segments on the side, but in that case, you'd need to lift it up and then sideways. What they did was simply to lift it up and fix it in place.
The Zhukov Tower, not only is it functional, it's intriguing to look at.
But this isn't Zhukov's first attempt at building a tower at this scale. Years earlier, he tried to build the Shavalovka Tower in Moscow. It was his first major construction project for the newly founded Soviet Union, and he had major plans. He designed it to be over 1,100 feet in height, but he faced an unexpected problem.
Not only would Zhukov's tower have dwarfed the Eiffel Tower, it would have been 3 American football fields tall. Imagine that.
A shortage of steel limited his ambitions, and the tower didn't even reach half the intended height.
I believe Zhukov could have done it. I think he could have got up to 300 meters because his structure was so incredibly elegant, so incredibly light, and so perfectly oriented with all the different steel beams coming in to create stability that I believe he would have done it.
For 2 years, Zhukov and his workers construct this breathtaking tower in Nizhny Novgorod. But will his groundbreaking design help power Soviet ambitions? And why was it abandoned? The abandoned Zhukov Tower in Western Russia stands at an impressive 420 feet tall. It's an electricity pylon made entirely out of steel, and the brainchild of Russian architect and engineer Vladimir Grigorovich Zhukov.
Zhukov's approach to engineering is from an extremely theoretical perspective. He's managed to turn an extremely complex mathematical formula into something very practical. And apparently it can be used in almost any function where you need to have something raised up into the sky.
In 1929, Zhukov completes his epic tower. And for years, the tower successfully carries electricity through its cables without incident.
Zhukov was a brilliant artist. Some people are talented in an artistic field, some are talented in mathematics. Zhukov was a brilliant artist and a brilliant engineer at the same time, so he was perfect. He was a pioneer in this area. Nobody else was doing it before him. He had a brilliant intuition that helped him to estimate risks and make it work.
The genius of Zhukov's tower inspires other engineers to replicate his revolutionary diagrid hyperboloid design. And today, his innovative approach can be seen in some of the world's greatest structures, including the Hearst Tower in New York City and King's Cross Station in London. In 1989, because the power line is rerouted, the Zhukov Tower is abandoned. But today, its engineering strength remains. And though Zhukov's name may be largely unknown, his legacy and structure still stand.
Zhukov may not be one of the most well-known mathematical or engineering names known to us here in the West, but what he created was totally unique. You can't just walk past one of Zhukov's towers and go, you're going to stop and look at it. And for me, that's enough to keep it preserved and keep generations to come interested.
1,100 miles away, on the northeastern coast of Germany, on the edge of the Baltic Sea, is what remains of a top-secret military installation. Spread across this windswept peninsula, hidden among the pine trees, are perplexing mounds of shattered concrete and twisted steel. Contaminated by chemicals and designated a no-go area, these abandoned underground bunkers, airfields, and buildings could once hold up to 12,000 workers. And before it all stands the remains of a 46-foot-high rocket.
What's forgotten is that the genesis of the space program wasn't these ambitious goals of putting a man on the moon. It was military. It was sending missiles straight up into space, not caring about where they go, but caring about how they come down and observing that so you can understand how you could use that information to attack your enemy. That was the start of the space program.
But what role did this remote facility play in the Nazi quest for world domination? And why was it abandoned? In 1936, Hitler has been in power for 3 years. With his eyes set on the military conquest, he sets out to create one of the largest armament centers in Europe with this, the infamous Peenemünde base. It's designed to be one of Germany's largest military proving grounds, and construction begins to create the first rocket testing range in the world.
Peenemünde was the first professional rocket project in Germany and in the world. Exploring space was a key topic of this future ideology.
Governments were willing to fund this program because they wanted to have this military dominance in Europe. And so that flow of funding and the focused effort meant that rocket technology accelerated in a very short amount of time.
And pushing Nazi Germany's long-range weapons program is the ambitious young engineer Wernher von Braun.
Wernher von Braun was the leading rocket engineer. He and his colleagues, they had this technological challenge and they wanted to solve it.
He was very enthusiastic about opening up the opportunities of rocketry for space exploration.
Completed in 1937, the whole complex cost the staggering modern-day equivalent of $25 billion. It consists of an assembly hall, a banked sand wall, and a launch pad, known as Prüfungsstand 7, or Test Stand 7.
The rockets were brought to the test stand in pieces, and then it was brought standing in a tower into the arena. This is the place where the rockets were launched exactly. They fired a little more than 300 rockets. They thought they were completely secret here. Nobody would find them.
In 1936, they had started their Peenemünde project to develop missiles of an entirely new type. And their first one was not a rocket. It was the buzz bomb, the V1. Its propulsion was by pulse jet engine.
With the pioneering success of the V1, engineers move on. And at the height of World War II, in October 1942, von Braun spearheads the first successful launch of his signature rocket, the V2.
Lüftung klar, Zündung klar, Vorstufe klar.
Reaching an astonishing altitude of 52 miles, this historic rocket reaches the upper atmosphere and launches Nazi military technology into the future. Standing 46 feet high, the V2 weighs 28,000 pounds and carries a ton of high explosive.
The V2 missile is in itself an extremely impressive weapon. And arguably, it's the start of putting man on the moon and rocket technology. But around that rocket, you've got the infrastructure and the facility that enabled the Germans to do what they did with it. We're talking about refueling the rocket. We're talking about producing that fuel in the first place. The logistics of getting everything that they needed, the monitoring systems in place, as well as actually getting that rocket actually firing.
But can the German engineers get this new rocket technology to reach outer space? And why was the Peenemünde base abandoned? During the Second World War, the Peenemünde test facility in northeast Germany is home to Nazi Germany's cutting-edge V2 rocket program. It embodies one of Hitler's great dreams, a powerful weapon to destroy his enemies, and a means of exploring the far reaches of space. But this new technology gets off to a rocky start.
The rockets never worked well. The whole history of testing and using it is a history of exploding and misfunctions.
But by June 1944, von Braun and his engineers make history when they vertically launch a V2 rocket from Test Stand 7 at Peenemünde. Traveling at 4 times the speed of sound, this historic rocket becomes the first to cross the boundaries of space. But during the war, the Nazis also dropped thousands of V2 warheads on Allied civilian targets.
The V2 was developed and being tested whilst the Germans were at war with the Allies. So, albeit that V2 rocket was not used for a purpose that we can celebrate, the engineering behind it was extremely thorough and very impressive.
Hitler was obsessed with wonder weapons, and that's where all the money went. And it was good for the US and the Allies at large because there weren't basic funding for infrastructure. There weren't enough tanks. People were riding bikes. It wasn't like state-of-the-art anything on the battlefield. And that's the irony.
At the end of World War II, Nazi Germany crumbles, and many of its key V2 launch sites, like Test Stand 7, are destroyed. And as part of Operation Paperclip, the Americans extricate von Braun and his team, who further the V2 rocket program for the United States. Once in America, his advanced military work forms the foundations for NASA's Apollo program, which eventually takes humans to the moon in the 1960s and 70s.
But I think even if that hadn't have been the motivation, we still look towards the stars. It's across all of our cultures to think about humans going out into the solar system and out into the cosmos. So the Second World War was the catalyst, but it was no means the reason for us having rocket technology.
Today, the launch sites at Peenemünde lie abandoned, slowly rotting away and disappearing into the forest. 900 miles east lies another, even more shocking structure. Hidden among the forests in Eastern Russia, just a short distance from Moscow, is a series of bizarre, alien-looking metal structures. Outfitted with numerous electricity-conducting coils, this apocalyptic machine towers over 100 feet in the air.
That thing is just immense. I think it's actually stunning. All the sort of balls and bits of steel. It's a man-made wonder of the world, I would say. I think it looks amazing.
But why were these strange-looking structures built? What purpose did they serve? And why were they abandoned? In the 1970s, during the Cold War, the Soviet Union is looking to boost its military defense against the United States. And to do that, the military, along with the government, try something radical: to generate huge, man-made bolts of lightning. The Soviet Union keeps this top-secret project classified, positioning it in a secluded forest.
The 60s and 70s, very engineering-focused architecture, and they say, oh, isn't that dirty and ugly? And no, I think there's actually some hidden beauty within that.
This is the Marx generator. Looking like a relic from a science fiction movie, these structures actually generate a shocking form of electricity. In fact, the electricity generated here dwarfs its rivals.
When you've got anything that sort of seems to be revolutionizing the world, it seems really cool and seems to be the future, people want to harness that.
And it has one terrifying purpose. For a fraction of a second, it's able to create an artificial blue and white lightning bolt. 650 feet long. To do this, the Marx generator must use all the energy the neighboring power stations can provide. 6 million volts. But what possible use could a man-made lightning bolt hold? In the 70s, both the East and West are too evenly matched for either side to risk a first military strike. So the Soviet Union focuses on defense and develops other ways to disable America's intercontinental ballistic missiles.
There was a wide variety of defenses and systems in place on both sides, and we had a pretty good idea of their missile capabilities, and I think they had a pretty good idea of the capabilities of our weaponry.
But can the Marx generator actually deter incoming missiles? Will it work? And why was it abandoned? Hidden among the forests in Istra, outside of Moscow, is a series of bizarre metal structures called the Marx generator. Designed to generate artificial lightning, this machine has one singular purpose: to strike down incoming American missiles.
In the 1970s, it's very important for protecting one's nuclear deterrent force in the homeland. And remember also, they're building anti-missile defenses against ballistic missiles.
But one side effect of exploding nuclear weapons is that they generate a massive surge of power called an electromagnetic pulse, or EMP, which can knock out all kinds of electronics, including the guidance systems of missiles.
We didn't quite understand the electromagnetic pulse that would have very likely have damaged our weaponry. But as we moved to more sophisticated systems, actually become more vulnerable to electromagnetic pulse.
The technology is developed and developed and developed. It's not as simple as just creating a wave. How do you turn, electrical power into an electromagnetic power that you can then transmit?
The Soviet military takes on this engineering challenge. Because lightning naturally generates an electromagnetic pulse, Soviet scientists try to create a machine to harness that power and paralyze America's missile arsenal.
We had cruise missiles, which were possibly our most effective weapon for targeting Soviet airspace because they flew nap of the Earth, and they are extremely difficult to pick up on any kind of radar, and certainly the radars they had in the 1970s.
This vulnerability makes the Marx generator even more crucial for the Soviets' defenses. What makes the lightning generator work are its coils. These coils create powerful electromagnetic pulses, which can be directed at incoming nuclear missiles, disabling them before hitting their targets.
The machine works the same as lightning. Planes are instructed to fly no more than 30 kilometers from a thundercloud. This is because strong electric fields reside in the atmosphere of the thundercloud, and a plane can conduct lightning. The lightning will cause an EMP and knock out the plane's electrics.
Coils are actually great at sending electromagnetic waves. It's developed your sort of new techniques to be able to harness essentially just these wiggles of electricity and magnetism into something useful.
Though it's never ultimately used to strike down incoming US missiles, the engineers keep the Marx machine in operation for 20 years. But there's a significant cost. Because the Marx machine must use 6 million volts of energy to work, it's very expensive to run. And when the Soviet Union collapses in 1991, finances for the Marx generator simply run out. Today, what could have been one of the world's ultimate weapons of defense is now left abandoned in a remote forest lair. Over 1,500 miles away, lying forgotten on a sheer-sided mountain in Derbyshire, in northern England, is the most ruined route in the whole of the British Isles. The abandoned road runs for nearly 12 miles through the remote and hilly Peak District, formerly connecting the cities of Sheffield and Manchester. It's one of the highest routes in England, at around 1,000 feet above sea level, in a location known locally as the Shivering Mountain.
It gives us a very, very clear reminder that things can go wrong, and this is how awfully they can go wrong as well.
But why was the road built? And why was it abandoned? In the early 19th century, during the heart of Britain's Industrial Revolution, industrialists need to provide a much-needed commercial lifeline between communities.
During the Industrial Revolution in Britain, there was industry popping up all over the country, but that industry was entirely dependent on the goods and materials coming in and going out. Transportation networks were critical.
So without the new roads, without the railway, without these new canals that had been dug around and this huge network that basically joined the whole country and made it one country, the Industrial Revolution just simply couldn't have happened.
These were the veins and the arteries that pumped life into the Industrial Revolution. You couldn't have one without the other.
To establish this vital link, engineers designed the Mam-Tor Road, one of the most treacherous routes in all of Britain. But to make it, engineers must face a big problem. The road crosses a range of steep mountains. And with a steep gradient, any straight road would be practically unusable by the horse-drawn wagons of the day.
There's a certain limitation as to how steep a road you can get a horse to draw an enormous, heavy load up. Mam Tor was chosen as a route because of the natural lie of the land. It had a much gentler slope, so as they could snake their way up, getting over the problem of having too steep roads. It was a road that horses could go up. But little did they know, because of the geology around it, it was probably the worst place they could have built it.
So what do the engineers try to overcome this difficult geology? And how did this remote mountain road become abandoned? In England's Peak District lies the treacherous Mam Tor Road. It snakes its way across 12 miles through some of the country's hilliest and most rugged terrain. For 19th century engineers to build around this steep gradient, they route the new road across the side of a 1,700-foot peak called Mam Tor. But an underlying issue with the geology blindsides their efforts.
So understanding the geology is so important, because at the end of the day, you can have a really strong road surface there, but if what's holding that up is really weak and not fit for purpose, then that strong road is not going to do anything useful.
Even for road builders today, the geology and the environment where you're going to place your road is probably the most important factor. You need to know how to deal with the geology and the environment that you've got, so that you've got a nice, solid, secure road that's going to stay there.
But the Mam Tor Road is anything but solid and secure. Unknown to the engineers, the road and the hill it sits on actually move at a rate of 1 foot every year.
You've got the road, which is built on a layer of sandstone, and underneath that is a layer of shale. Now, shale is extremely unstable, especially in wintertime, when you've got rainwater and precipitation draining down through the sandstone and making that layer of shale really quite fluid almost. So that is the critical factor at Mam Tor.
Soon after construction, the Mam Tor Road begins to split and buckle as the surface of the hill continues to move. To compensate, engineers make simple repairs throughout much of the 19th century. But by the 20th century, they try to hold the road together with a newly developed material, tarmac.
So the introduction of tarmac made it easier to actually repair the surface of the road, because you could come and mix the rocks with this kind of bitumen, sticky material and create a nice solid surface. But the problem again here is that the bottom of it, the foundations, are just simply slipping away. So it doesn't matter how good your surface is on top. If the bottom's not strong enough, then the top's not going to do very much.
Despite the new tarmac surface, the slope keeps moving the road.
Over time, there have been a number of attempts to try and shore up the road, to stop it from slipping away. The biggest of those, probably in 1949, there was a big slippage. So what they did, they dug further back into the hillside, and then on the lower side of the road, built up the road with a load of limestone on top.
It actually made things worse, because not only had they cut into the geology and actually encouraged for more sliding to happen, they then also overloaded the road surface, and all that happened was the whole thing started moving in a way that they hadn't even seen before.
By putting a load more mass on the kind of outer edge, there was even more slippage. It's almost like sticking a huge weight off the wrong side of the Leaning Tower of Pisa. It's gonna go.
Structural engineers estimate that landslides containing about 45 million tons of earth and rock have caused the road to slip dramatically, 131 feet downhill.
There was a decision made to shelve it because it was just getting to a stage where it was completely unusable. And I guess the balance you need to find is, well, how much is it going to cost to create a new road and just completely bypass what's there and what's been destroyed? And how much is it going to cost to fix the original pathway? And if the new one is actually cheaper and perhaps even better for the environment than trying to fix this old one, then you go for the new one.
But there becomes a point where you just have to say, do you know what? Enough's enough. Nature's beaten us. Let's close it.
With ever-changing geology and constant landslides, local authorities closed the Mam-Tor Road to all vehicles in 1979. Today, this road lies ruined and broken, abandoned on the peaks of Derbyshire in England. Though inaccessible to vehicles, the Mam-Tor Road is now popular with hikers and bikers. On the opposite side of the planet, in Cape Town, South Africa, an abandoned road that runs through the heart of the city has become a notorious icon. Made out of reinforced concrete, it silently towers, but mysteriously ends above the city.
It's very unusual for authorities to leave the catastrophe of this great public works suspended in the air.
It's a piece of infrastructure, it's a piece of civil engineering that you notice because it's not finished.
But why was this project started? And why was it abandoned? In the 1930s, the city of Cape Town reclaims 480 acres of land from the sea, known as the foreshore. To incorporate it into the city, urban planners need a new road layout. They decide to build a large freeway connecting the port with the city.
So you can see we're right in the center of downtown, what's now downtown Cape Town. Ahead of us, we've got the port, and we've got the other part of the freeway. And this whole area from the port until just beyond these high-rises, it's part of the foreshore, and that's really where this story begins.
This is the severed Foreshore Freeway Bridge. Now known as the Invisible Bridge, planning starts in the early 1940s, but the effort soon faces problems.
Throughout history, there are bucket loads of examples in civil engineering where the final outcome is a compromise between maybe function and form. And often what you end up with is something pretty boring or enormously elaborate. But there are so many stakeholders in these kind of projects that it's never one person's decision.
There were two main parties that were interested in this land. One was the city itself, and one was the Port Authority. But the city of Cape Town, they had this vision that when Europeans arrived by cruise ship at the port, they would have this monumental entrance. It would be like a gateway to Africa.
But which side will get their plan approved? The port authorities or the city? And why is this bridge abandoned? In the heart of Cape Town are the remains of the Foreshore Freeway Bridge. In the 1940s, the city of Cape Town wants a grand French design and layout, while the port prefers simple function over form. But in the 1950s, the new head of city engineering, Solomon Morris, proposes a new direction.
The reason why the freeway was styled the way it was not obvious to most. It was styled as this huge sort of freeway, Autobahn in Cape Town, because that is what the lobbyists, the US car manufacturers wanted, not only in Cape Town, but all around the world. Big motorways that will be filled with big Buicks, big Chevys, big American cars.
Over 20 years of wrangling, the plan, which more or less looks like what we have today, was developed in 1963, until finally, in the late 1960s, some of the construction actually began.
But by the 1970s, South African politics impact the Foreshore Freeway. apartheid laws lead to the forced clearance of an ethnically diverse area called District 6.
In South Africa, native protests flared against apartheid and passbook law. 100 died when police fired on demonstrators at Sharpeville.
The South African apartheid government chose not to complete the bridge and not to spend those funds on the freeway, but rather to relocate a multi-ethnic community that was in the heart of prime central Cape Town to someplace less important. It was all about focus, it was all about funds.
Construction still proceeds slowly, but with only the elevated sections of the roadway left to build, work mysteriously comes to a halt in 1977.
There are a couple of theories why the freeway was never completed and left just suspended in air like you see it today. One is that there's a shopkeeper whose property was right in the critical path of the bridge he wouldn't sell. The other theory, which I really like, is that the engineer who designed the whole thing realized the two ends of the bridge would never meet.
Today, the Foreshore Freeway Bridge sits abandoned, high above the streets of the city, devoid of any cars, any life, or any purpose. But Cape Town's inventive citizens are finding a variety of uses for the concrete white elephant.
The aborted freeway has been used for many artistic endeavors since it was abandoned. Movie sets, supermodel shoots, that kind of thing. But perhaps the most innovative is it was used as the set for the 2010 Football World Cup. And these giant horns that you hear in the stadium, they had a huge one mounted right there, but it was so loud. People were claiming they had heart attacks and there were traffic accidents, so the whole thing had to be abandoned.